Greetings, parasitic ecologists. In a previous lecture, we talked about the generic trematode life cycle as exemplified by Euhaplorchus californiensis, the stereotypical three-host life cycle that most trematodes follow. But of course, there are tens of thousands of species of trematodes in the world, and as a result, there are tens of thousands of different ways for the trematode life cycle to play out. It's not enough just to know this typical three-host life cycle for the trematodes. We need to know that trematodes' life cycles are variations on a theme, meaning that all trematode species follow the same basic pattern, but each one plays a slightly different version of that pattern. In this lecture, I want to introduce you to the idea of variations on a theme and show you 3 trematode species who each play a different variation. If you're a musician or if you've studied music theory in the past, you might know the term variations on a theme. The idea is that there's a central motif or melody in a piece of music, and that motif reappears again and again throughout the composition, maybe with different instrumentation or in a different key, or just giving a different flavor to that motif as it is repeated over and over again. Let's look at a musical example before we go to the parasitological examples. I really never thought I'd have to pull out this tool in my career as a parasitologist, but it looks like it's time to put my high school band skills back to work. I'm going to play you a few different variations on the theme from Harry Potter. They're all drawn straight from the score of the movies, which was composed by John Williams. This little melody or motif is called Hedwig's theme. You'll be able to hear the key melody repeat itself through 4 variations, but you'll also be able to hear how the 4 passages differ. In tone, rhythm, key, in mood, they'll be the same, but different. Okay, now listen for Hedwig's theme in this first passage, which is from The Philosopher's Stone. Bright, curious, whimsical, maybe a little bit mysterious. Now remember that motif, and I'll play the next passage, which is from The Chamber of Secrets. Okay, a little bit more momentum here, less brightness, less whimsy. We're in a different key, and you can hear from the music that we're moving forward. Maybe something a little forbidding is in front of us. It's the same as the first passage, but different in small ways. Now, a passage from The Goblet of Fire. This one has a different rhythm than the first 2. A little bit more formal, maybe a little bit more foreboding. And now, one last passage from The Half-Blood Prince. This one is deconstructed, and you can almost feel our familiar old melody falling apart, falling to pieces. It's the same, but different. In the same way, the trematodes repeat themselves over and over again. Same melody, but just slightly different variations on that theme, as we will see. Many trematode species do have this classic 3-host life cycle, where they infect snails as the first intermediate host, and then encyst in a second intermediate host, and finally reach maturity in the gut of their vertebrate definitive host. But other trematode species put their own twist on this central pattern. Let's check out how different trematode species do it their own way through the lens of 3 different aquatic trematode species. The 3 that we're going to focus on are Fasciola hepatica, Sacculorhina magna acetabula, and Schistosoma mansoni. Among these species, Fasciola hepatica and Schistosoma mansoni are both found in freshwater. Sacculorhina magna acetabula is marine. Here's variation number 1. Fasciola hepatica can infect humans, but in general, it's a bigger problem for livestock than it is for people. I used to work in Senegal, where people keep herds of cows, and the workers in the slaughterhouses there saw Fasciola hepatica in the cows that they butchered all the time. For the vertebrate host, whether a human, cow, or sheep, the worm Fasciola hepatica causes the disease fascioliasis. Fasciola hepatica is only one of many trematodes that can infect people. We call these trematode-caused diseases the foodborne trematodiases because the worms infect people via trophic transmission. It's pretty rare for parasite species to have common names, but Fasciola hepatica actually has a few, probably because it is such a familiar species to farmers. It's sometimes called the common liver fluke, sheep liver fluke, or, more ominously, liver rot. Before we get to the life cycle, let me show you the adult form of this trematode, because it is really quite impressive. In part, because the adult stage of Fasciola hepatica is extremely large. You can see from the scale in this picture that adults can grow to several centimeters in length in the vertebrate host. It's got a really distinctive appearance. It's kind of leaf-shaped. And you can see, like most trematodes, this one has both an oral sucker and an acetabulum, or a ventral sucker. Both of the suckers are located north of the mid-body, or the equator, on these worms. So they're not equatorial. They're in the anterior portion of the worm, or the head end. In this picture, the worm on the left is laying on its back, belly up, so that you can see the oral and the ventral suckers, which are always located on this ventral side of the worm. The worm on the right is laying on its belly, so you can see its dorsal side. For that worm, the head is the little cone rising up out of the flat leaf shape of its body in the upper left. Check out the branching dendritic patterns on these worms. Those are actually intestines. All of those beautiful patterns that appear on the lateral margins and the posterior margin of the worm, these are all branching parts of the intestine. Here's another really good view of the dendritic intestinal cechi of this worm. This is what the worm would look like if you just slapped it down on the lab table after pulling it out of the bile duct of a cow. But if you then killed the worm, stained it, and smushed it really flat on a microscope slide, you could see the branches of the intestinal cechi even better. And all of those beautiful branches that you see in this picture are the intestinal cechi of the worm. Now, it might seem kind of wasteful to have such an elaborate intestine, but it actually serves a really important function. It maximizes the surface area over which the worm can absorb the food that it eats. And as a result, it's really efficient at absorbing that food. Remember, we've seen that efficiency before in other parasite species. Being really good at absorbing nutrients is a common feature across the parasites. The really classic giveaway of Fasciola hepatica and other worms in its family is the fact that it has shoulders. It has something called an oral cone, which surrounds the oral sucker, and then just at the level of the ventral sucker or the acetabulum, you'll see that there are little shoulders. You can see that really well in the fresh specimens, right? For the worm on the left, the oral cone is pointing to the lower right. For the worm on the right, the oral cone is pointing toward the upper left. Check out those shoulders. Okay, now you've appreciated the beauty of the adult form of Fasciola hepatica, the form that might be encountered in livestock or in ourselves. So let's check out the life cycle and see how it varies from our theme. Here's the life cycle of Fasciola hepatica. The vertebrate definitive hosts of Fasciola hepatica are usually ruminants like cows or sheep, but people can be infected as well. No matter who the definitive host is, that host poops out eggs into fresh water like streams or ponds or lakes. Those eggs then hatch, releasing a ciliated larval stage called a myricidium. This should all sound really familiar so far. The myricidia go on to infect snails, and inside of those snails, they take over the visceral hump, they consume the snail's gonad, castrate the snail, turn the snail into a zombie, and then that snail just pumps out little Fasciola hepatica larvae for the rest of its life. Remember that the same thing happens for Euhaplorchus californiensis, our stereotypical trematode, with the stereotypical trematode life cycle. Now, those Fasciola hepatica cercariae find their way out of the snail host and into the water column, and here is where the variation comes in. Rather than insisting on a second intermediate host like a fish or a crab, this particular worm does something pretty unusual among the trematodes. It forms a cyst on aquatic vegetation. It just kind of hangs out on the surface of aquatic vegetation, forms a resistant cyst called a metacercaria, and it lays in wait. It's waiting for a cow or a sheep to come along and graze in that saturated bed of aquatic vegetation. Or perhaps for a person to come along and eat that aquatic vegetation, as people sometimes do. Once it's eaten, that metacercaria bursts open in the intestine of its definitive host and goes on to become an adult. But again, one more variation. Rather than settling down in the gut as our stereotypical trematode might, Fasciola hepatica finds its way to the liver, just as its Latin name suggests. And in the bile ducts that drain the liver is where you'll find it when you're slaughtering cows. So a few variations from the stereotypical trematode life cycle. First, Fasciola hepatica forms its metacercaria on top of aquatic vegetation rather than inside of a second intermediate host. Second, it inhabits the bile ducts and the liver rather than the intestine of its vertebrate definitive host. This parasite is global. We see it where sheep or cattle are raised, so any place where sheep or cattle are able to graze in water bodies where aquatic vegetation is growing, you are likely to find fascioliasis. Even here in the US, it's a common parasite of livestock. People become infected when they eat aquatic vegetation, and in different parts of the world, people prefer different kinds of aquatic vegetation. In North America and in Europe, the thing that most commonly gets people infected is watercress, which is a really delicious salad green that's grown in fresh water and can be a good place for Fasciola hepatica metacercaria to settle down. Once a metacercaria does settle down, it's able to make its way into the mouth and then the intestine of a ruminant or a person. And from there, it finds its way up to the bile duct. It then hangs out in the bile duct and ends up kind of gnawing away at the epithelium of that duct. Fasciola hepatica can also make its way into the liver and create little tunnels through the liver. In the process, it compromises the parenchyma, or living and useful tissue of the liver. It also erodes the bile ducts that drain away from the liver, compromising their efficiency as well. In fact, in infected definitive hosts, we often see a symptom called pipe stem fibrosis, which is what happens when these little worms are gnawing away on the bile passages. The gnawing can cause inflammation and edema. Remember that edema is swelling. And that produces fibrous tissue in the bile duct, and it turns the ducts from nice and flexible and pliable to being really rigid and unable to bend, and often a little bit brittle as well, which is not what you want your bile passages to be. Finally, the migrating juveniles can cause ulcers in other locations, ectopic locations, as they wander around looking for a place to finally settle down, mate, and produce eggs of their own. Fascioliasis is a super important disease of livestock, but it's pretty well controlled in the US because we're able to give our cows and sheep plenty of drugs to clear them of these flatworm parasites. There is an excellent drug for this called praziquantel, which is also used in humans to clear flatworm parasites. Where fasciola becomes a problem is in places where people can't afford veterinary drugs like praziquantel, which is quite expensive. And so Fasciola hepatica is a major problem for livestock in the global south and anywhere people can't afford expensive veterinary drugs. I've just discussed Fasciola hepatica, where the variation on our theme is that this parasite insists on aquatic vegetation instead of inside animals as their second intermediate host. And the adult worms inhabit the liver and the bile ducts of their definitive host instead of the intestine. In the next video, we'll continue with the second and third variations on our theme. I'll see you in the next video.